So I have this problem. I want to know if this series converges or diverges. And I'm looking at it. And the first thing I'm thinking of in my head is about the dominant terms in the numerator and the denominator. And what I mean by dominant term is the degree, the degree term, the whatever determines the degree. What the degree of the numerator is what? 0. So it's just the 1. And then the degree of the denominator is 2. So as I'm looking at this, I'm calling this the dominant term. And actually, I heard that from the grad student last week or 2 weeks ago. And I read it in the book. In the old videos, I've called it the boss. Those are the bosses, the dominant term. They determine what's happening in this problem. And so I want to compare this series to the series of 1 over n squared. So we look at the dominant terms. I'm sure I misspelled dominant there. I'm going to call it the boss. We look at the boss terms in the numerator and denominator. And for this problem, they determine your series B sub n. They determine that I want series B sub n to be the series of 1 over n squared. And you know, sometimes they'll write, and maybe I should have written it, n is gone from 1 to infinity. And so I'll write it right here. So I know what happens with B sub n. What's happening with B sub n? Well, the series. Well, B sub n is going to 0. You're right. The sequence is going to 0. The series is converging or diverging? Converging. How do you know? It's a P series, and P is 2. Is greater than 1. So series 1 over n squared, n goes from 1 to infinity, converges because it is a P series and P, which is 2, is greater than 1. And I'm looking at, I have this then, I have, so A sub n is 1 over n squared plus 3n plus 10. And we have B sub n is 1 over n squared. How do they fit together inequality-wise? Which ones? B sub n is bigger than A sub n. Because if you look at the denominator of A sub n, I'm adding some terms in the denominator. The numerator staying the same. So as n is 1 or 2 or 3 or whatever, we have that A sub n is less than or equal to B sub n for all n. And if it's for n eventually, that's okay. Well, this meets the conditions of the comparison test. So I know that then the series A sub n converges. So I'll write by the comparison test we have that the series as n goes from 1 to infinity of 1 over n squared plus 3n plus 10 also converges.